Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate really exciting concepts here about power series, and we're going to investigate the convergence of the sum 1 to infinity of x minus 1 to the n over n cubed 3 to the n. Just want to check and make sure I copied down that problem correctly. Yep. Alright, so when investigating the convergence of a power series, the ratio test is the gold standard. So again, ratio test, you're looking at limit as n goes to infinity of a to the n plus 1 over a to the n. And for this thing to converge, this has to be, the absolute value of this ratio has to be less than 1. So what that means in this problem is limit as n goes to infinity of x minus 1 to the n plus 1 over n plus 1 cubed times 3 to the n plus 1 divided by this. And I'm going to go ahead and change that division to a multiplication. N cubed 3 to the n over x minus 1 to the n. This limit has to be bound between minus 1 and 1. I'll go ahead and get the limit figured out, and then we'll write the inequality statement. So limit as n goes to infinity. Alright, so let's kind of group these things. X minus 1 to the n plus 1 over x minus 1 to the n. That's x minus 1. N cubed over n plus 1, the quantity cubed. I'll go ahead and just leave those kind of grouped together. And, okay, these 3 to the n's here, we got a 3 to the n up top, 3 to the n plus 1 on the bottom. That's going to give us a 1/3. All right, now we take limit as n goes to infinity. This ratio here is 1. This is a 1/3. So what we're going to have is x minus 1 over 3 when n goes to infinity. And for convergence, this limit has to be bound between minus 1 and 1. Now, the x minus 1 over 3, we can solve this for x by multiplying by 3. So the new line is going to read minus 3 is less than x minus 1 is less than 3. You can add 1 to everything. This is going to read minus 2 is less than x is less than 4. And this is what's known as our interval of convergence. Right? A lot of people, or textbooks like to ask about the radius of convergence, and that's basically how far x can vary from the center of this and still converge. The distance between these 2 points is 6, and half of that is 3. So the radius of convergence is 3. Now, when you apply the ratio test, it's important to note that it is inconclusive at the endpoints. So the minus 1 and the 1 are inconclusive. That's why this is strictly less than, strictly less than. So we have to take a look at the equality part now. So I'm going to look at the left-hand side first, and we're taking a look at when x minus 1 over 3 is equal to negative 1. And I'm going to rewrite our series here. Sum n equals 1 to infinity of, now this is x minus 1 to the n, this is 3 to the n. So this is x minus 1 over 3 to the n. So we can write that as minus 1 to the n, and then there's this over n cubed. Okay. So what I've done is written this x minus 1 to the x minus 1 over 3 to the n, and replaced the x minus 1 over 3 with negative 1. And what I'm doing is I'm investigating the equality part, whether or not we can put equality on that inequality statement. Now when we look at this, this is an alternating series. However, even ignoring the alternating part, sum 1 to infinity of 1 over n cubed is a convergent p-series. Therefore, we can go back to our inequality statement here and add that, because that thing is absolutely convergent on that endpoint. Okay. Now we're going to investigate the right-hand side. when x minus 1 over 3 is equal to 1, our series is now sum n equals 0 to infinity. And again, x minus 1 over 3 to the n now becomes 1 to the n. And again, we still have this 1 over n cubed. 1 to the n is just 1, and the sum of 1 over n cubed, I think this was starting at 1, not 0, but sum from 1 to infinity of 1 over n cubed is a convergent p-series. Therefore, we can go back to our inequality statement and do this. So, again, one thing I'd like to point out, this part of it is coming from the ratio test. Adding the equals on the endpoints is coming from analyzing the endpoints independently. That's not coming from the ratio test, because the ratio test is inconclusive when the ratio is 1. So, hope this video helps demonstrate how to analyze the convergence of a power series. Have a great day.